Everyone, welcome to today's video. We are going to solve sorted insert for circular linked list. In this question, we are given a linked list of length n and we have to insert an element data such that the remaining linked list, the linked list which thus forms, will also be in a sorted order, okay, and is connected, okay, circularly connected. So see in example 2, you have four elements 1, 4, 7, and 9. You have to insert 5, which will be after 4 and before 7, and thus this is our result 1, 4, 5, 7, 9. The remaining linked list, the succeeding linked list which thus formed, will also be a linked list in sorted order and in circular manner. Similarly, for example 2, you have to return 1, 2, 4 is given and you have to insert 2. Similarly, you will get 1, 2, 2, and 4. 2 will be inserted in between. Okay, so there are three conditions. Either the linked list will be empty, okay, or the linked list or the element we have to insert will be in the beginning, or the element we have to insert will be in middle or at the end. Okay, there are three conditions. The first condition, if not head, if there is no linked list, if there is no linked list given, we are given nothing, okay, in that case this current node which I've created, new node equals to node data, okay, this node will be the first node, will be the first node. And the most important thing is, since this is circular linked list, this node will point to itself. Thus new node dot next equal new node, this node will point to itself. Cool. So this was our first condition where we are not having any linked list. We are having nothing. Just we have data to insert. Thus it will be inserted in the beginning, in just the very node of the linked list, and it will point to itself. Now there's a condition. If we have to insert at the beginning, which means the data which you have to insert is less than what? Less than or equal to the head, the current node. Okay, the current head, current node. Okay. In that case, we'll see if head dot data, head is the current right now. Head dot data greater than or equal to data. It means our data which you have to insert is either less than or equal to the head. Okay, head node. In that case, we'll create empty variable head, which will point to the current node, and while this current dot next not equal to head, which means while current dot next not equal to head means while it does not reaches the end, it will point to head only when it reaches the end, because it is circular and self pointing. The last node will point to the first node. In that case, while current node not equal to head, which means while we have not reached the end, current, we will just we will just keep on shifting the current element towards the right side. New node new node next of new node will hold the head, but wait a second, we'll do two operations here. So the next of new node will hold the head, okay, because it will be the first node and head is the first current, and new node will be the new node will be the node which I will be adding in the beginning of head. So new node will become the first node and head will become the second node. Okay, in that case, the next of the new node, which is the first right now, which we have added, should point to the second element, which is head. Okay, and and current dot next, current dot next should point to new node, because dot current right now has been moved to the end, the last node. Current right now has been moved to the end, last node, and last node should always point to the first node. Okay, and in that case, return the new node. Return the new node. If that is also not the case, which means we are not having any empty linked list. We have linked list to begin with, and the element which we are about to insert is not less than or equal to the first head node. In that case, which means it all boils down to, we will be inserting the element either in the middle or in the end, either in the middle or in the end of linked list. Okay, current equals to head, current will point to the head node, Now, while true, while this is true, it will go on forever. Okay, it will go on forever. Now, if two conditions, if current dot next dot data, the current head dot next, the second element's data is greater than or equal to data. The data of the second element, current dot next dot data, is greater than or equal to the data, which means the current value which we want to insert. Data is what we have to insert. Okay, there's a name mismatch given by this geeks for geeks compiler. It should not be data, it should have been something else in order to minimize the confusion, but it is what it is, so you'll have to bear with it. Now, current.next.data, the second element's data, is greater than or equal to data. Or one more conditions, if current.next is equal to head. There are two conditions. Okay, current.next equal to head means we have reached the end. Okay, we have reached the end. So there are two conditions to be followed over here. Either it should be in the middle or in the end. Either in the middle or in the end. Just remember that. So new node dot next will hold current dot next. New node dot next will point to the will now store current dot next. Okay. And apart from that, one more condition, one more change. Current dot next will point to new node. Will point to new node. Okay. Why there are these two conditions? Now new node which we have formed right now. The next of it should point to the current dot next. Current dot next is what? Current dot next is what? The element which we were currently at previously. Okay, it can be in the middle one or at the end one. Okay, and the current of next should point to the new node. Current of next should point to the new node. It can be in the end, it can be in the begin in the middle. Okay, return head at the end. And if we are not able to do any such thing, move the current with one step ahead. Move the current one step ahead, and this should do our job. Let me submit it and test how far we have came. Okay, there's one issue. Okay, okay, in this code we have not. Okay, we have not inserted, so to say, in this example. Okay, and in this node it has to be in the end. Let me see what's the issue. Okay, okay, so now I've figured out. I just returned outside this function, but it should not be the case. It should have been. Otherwise it will not, it will not break the loop. Okay, now it should do the job. And let me submit. Yeah, this time it is running. Yeah, this time it is. Okay, time limit exceed. Why? Yeah, yeah. See, it is taking very less time, but sometimes CFG compiler goes above head. So I hope you enjoyed it and learned a new concept. Thank you. Have a nice day.